Thank you for joining us today as we take you through our project plans to help make science and engineering come to life. My name is Ian Sanford and this is Team Colorado. Before we jump in, I'd like to introduce the team that was able to make it all happen. AJ Sparra is an aspiring engineering physics major who specializes in computer-aided design. Hannah Nachtigal, our video genius, is a mechanical engineer who is also very skilled at design. Responsible for all of our electronics is Rachel Shea, an environmental engineer. Saad Almatari, another environmental engineer, was our point man for reports and analysis. Finally, I myself am a mechanical engineer who handled logistics. Back in February, we met with our client, a Miss Kim Elder from Community Montessori Elementary School in Boulder, Colorado. She asked that we create a visual aid to demonstrate an engineering principle of our choice to a young audience. In the hope that we could spark an early interest in engineering, we launched into the design process. To kickstart the process, we brainstormed several different principles and demonstrations. Once we had all our ideas documented, we jumped right into our decision matrix, where we narrowed down which idea met all our constraints. We decided to go with making a vacuum chamber to demonstrate the effects of gravity on mass-differing objects, because it proved to be the safest and most cost-efficient solution, and we believe it would be valuable to young kids. With our choices narrowed to one, we began the process of prototyping. Our prototype was a Lego model of the chamber, and it demonstrated two doors opening at the top of the chamber, allowing two objects to fall. The prototype we made exemplified the structure of the box, which had to be strong enough to withstand the stresses caused by the pressure difference. Finally, we used online CAD tools to design the look of our finished product. We used a block diagram to show the different systems of our gravity demonstrating vacuum chamber. We will use a pump to create the vacuum and an Arduino board to carry out two electronic functions, the first being a button to release the objects, and the second being lights that turn on once the objects land. Due to our inability to manufacture the box itself, we had to rely heavily on various computer programs to model the product. This first video demonstrates the overall function of the vacuum and how we hoped it would look with two different objects falling together. We then modeled the electronic systems of the product using Arduino and TINKERCAD. This video shows how the press of a button would give power to a motor, which would in turn open the doors at the top of the chamber. The second electronic function incorporates a sensor at the bottom of the chamber so that we could give an extra visual representation of when the objects simultaneously hit the ground. Our final simulation shows the different components of our final product and how they would be constructed. The design has acrylic sides to the chamber, which required lengthy stress calculations to ensure no implosion would occur. It also has steel braces at the corners and a hollow box base constructed from plywood. Adding up all of the components' prices, we have estimated the final product cost to be $467. This is almost spot on with our planned budget. This project has given us insight on the power of the design process and the importance of working together as a team. In the future, our group would like to get an earlier start on things, but when the time comes for another project, we know we will be eager and ready. I hope you enjoyed this video, and thank you for watching.